today's video, we are going to be looking at permutation and combination. But more specifically, in this video, we are going to be looking at permutation alone. We will discuss the three different types of permutation and solve multiple examples to back up all our explanations. Then in the next video, we are going to be looking into combinations. Alright, so basically, whenever we consider the arrangement of objects, taking into account the different orders of arrangement, it's simply called permutation. So in permutation, we are basically arranging objects and then considering the order to which these objects are being arranged. Now, one of the key things to understand in the subject of permutation and combination is the word factorial. Okay, I'm sure you've heard about this by now, but the word factorial is a very key concept in this subject of permutation and combination, symbolized by this. Now, factorial simply means successive multiplication of values in their decreasing order. For instance, if I'm to find n factorial, this is actually going to be equal to n multiplying by n minus 1, multiplying by n minus 2, multiplying by n minus 3, and so on till you get up to 1, multiplying by 1. It has to end in 1. So that means if I'm asked to find 3 factorial, this actually means 3 multiplied by 3 minus 1 multiplies 3 minus 1, okay, multiplies 3 minus 2, multiplies, okay, it ends at 3 minus 2, which is actually 1, right? So this is actually 3 multiplies 3 minus 1 is 2, multiplies 3 minus 2 is 1, and then you have this to simply be what? 6. In the same way, if I'm asked to find the factorial or 7 factorial, you also start from 7, then multiply by 6, multiply by 5, multiply by 4, multiply by 3, multiply by 2, multiply by 1, and this simply gives us 7 factorial. So 7 factorial simply gives us 5040. So this the term factorial is a very important term in the subject of permutation, right? So like I said, in permutation we are more interested in how numbers, the orders in which numbers or words are being arranged. Now let's say, for instance, we are asked to find the permutation of the word Kano. Okay, let's say we are asked to find the permutation of the word Kano. What you do is you calculate or you count the total number of words here. Kano is made up of 4-letter words, K-A-N-O. So this simply means by permutation, Kano is given simply as what? 4 factorial by permutation. So this is equal to 4 times 3 times 2 times 1. So this means that Kano can be arranged in 4 times 3 times 2 times 1, which simply gives us 24 ways. So permutation is basically the ways in which objects can be orderly arranged. So the letter Kano can be arranged in 24 ways. So you can go ahead to want to toggle the positions. First you have K-A-N-O. Next you can have O-K-A-N. Next you can have N-K-A-O. You know, just keep on toggling the position. You see that you can be able to toggle the positions in 24 different ways. That is the essence of permutation. The manner of arranging objects is simply called permutation. Now, permutation can also be done taking a particular arrangement at a time. Permutation can be done taking a particular arrangement at a time. So when we do that, let's say we want to permutate n, taking arrow at a time, okay? Let's say we want to permutate n. Permutate n, taking arrow at a time. Taking arrow at a time. In that case, we simply represent this using n permutation arrow to be equal to, the formula is simply n factorial all over n minus arrow factorial. So whenever you want to permutate a given number, taking a particular order or position at a time, this is how you represent it. For instance, let's say we are asked to find the number of ways the first and second positions can be taken by 4 people in a race, assuming there is no tie. Now, we have a total number of 4 people, which means n is equal to 4, and we are being asked in how many ways can these 4 people be arranged such that we take first and second position. Okay, so in how many ways can the first and second position be taken by 4 people in a race? So this is 4 people taking 2 positions at a time, so which means r is equal to 2. R is equal to 2. So permutation can also be arranged in this way, taking a particular position or order at a time. Like in this question, in how many ways can 4 athletes take 2 positions at a time? Simple. So this can be written simply as 4 permutation R. 4 permutation R, which is 4 permutation 2, yeah? So this is actually 4 factorial all over 4 minus 2 factorial. So 4 factorial is actually 4 times, okay, let's still keep it as 4 factorial for now and evaluate the denominator. So 4 factorial all over 4 minus 2 becomes 2 factorial. So 4 factorial is simply 4 times 3. You can simply end it at 2 factorial all over 2 factorial, such that 2 factorial cancels 2 factorial. You're left with 4 times 3. So 4 permutation 2 is actually 4 times 3, which simply gives us 12 ways. So simply, the number of ways in which the first and second positions can be taken by 4 people in a race is simply 12 ways. So always keep that in mind. You could be asked to permutate or find the number of ways in which a particular number can be arranged within a specific order. So like in this case, we are considering first and second position when 4 people engage in a race. So which means 4 people taking 2 at a time. Now, suppose we are asked to find the number of ways in which 5 people can be arranged around a table. So you know that table is usually cyclic in nature, something like this. So if you're asked to find 5 ways, find the number of ways in which 5 people can be arranged around a table. So in this case, we're talking about cyclic permutation. Since a cycle has no beginning and it has no end, the only way we can do this is by fixing one of the person at one point of the table. So you hold one person fixed, then you spread the other 4 people remaining. So if you are asked to arrange, okay, 5 people around a table. Alright, so like I said, you hold one person constant. Simply fix one person, and if you do that, it means you are left with 4 people, right? You're left with 4 people. So that's the way to tackle cyclic permutation. You keep one person fixed, then you arrange the other 4 people around. So by this, you can have this to actually be equal to 1 times 4 factorial. So this is how you can arrange 5 people around a table. You keep one person fixed simply because a table is a cycle, has no beginning, it has no end. So the only way you can be able to do this is by holding one person as a reference point. So you keep it fixed, then arrange the other 4 people. So that means 1 times 4 factorial. So this is going to be equal to 1 times 4 by 3 by 2 by 1, which still remains 24 ways. So we can arrange 5 people around a table in 24 ways. So that means if you're asked to arrange 7 people around a table, just like we did, if you're asked to arrange 7 people or 7 people in a board of directors meetings, right? You know that the table is usually round. Since the table is round, it means you're going to be keeping one person fixed. Then you arrange the other 6. So that becomes 1 times 6 factorial. So this is going to be equal to 1 times 6 times 5 times 4 times 3 times 2. And you have this to be equal to 720 ways. Okay, 720 ways. 720 ways. So this is the number of ways in which you can arrange 7 people in a board of directors meeting or on a round table, right? So whenever it has to do with cyclic permutation, you keep one fixed, then you spread the remaining 6, or you permutate the remaining numbers. Okay, the next type of permutation are permutation involving indistinguishable objects. Permutation involving indistinguishable objects. So what do I mean by indistinguishable objects? Let's say, for instance, you're asked to permutate the word Abuja. Let's say you're asked to permutate the word Abuja. Okay? So in this case now, you see that the letter A appeared 2 times. So you cannot be able to differentiate them or distinguish them. So this is now permutation of indistinguishable objects. If you ask to permutate the word Abuja, A appeared 2 times. These 2 letters A are indistinguishable, okay? The 2 A's are indistinguishable. The 2 A's are indistinguishable. So what we do is simply, first you count the total number of alphabet or letters that makes up the word Abuja. So you have A, B, U, J, A, which is about 5-letter words. Now, since we have 2 alphabets being indistinguishable, when permutating such words that involves indistinguishable objects, you simply do n factorial all over the total number of indistinguishable objects factorial, right? So for instance, it can be n1 factorial, it can be n2 factorial, times it can be n3 factorial. This means if I have up to different number, let's say 3 different number of indistinguishable objects, then this is how you permutate. Where n factorial is the total number of the letters that makes up the word. n1 factorial simply means a particular number that appeared more than once. n2 factorial means the particular total number of words that appeared more than the second time again, and then n3 for the third one. For instance, in the word excellence, okay, so you see that in excellence I have 1, 2, 3, 4 E's, right? In excellence I have 4 E's, so you can simply say n1 is equal to, n1 is equal to 4E, because we have 4 different letters of E in excellence. Then again we can say n2 is equal to, so we have about 2 letters of the word, we have about 2 letters C in this word, so n2 is simply 2C. Okay, then any other word appearing here, I think we have L twice as well, so n3 is 2L, so the letter L appeared actually 2 times. So if you're asked to find the permutation of the word excellence, the first thing you do is count the total number of letters that makes up the word excellence. Then you pick out the different number of letters that repeated or that are indistinguishable. So we have 4E, so which means they are indistinguishable. We have 2L, also indistinguishable, and we have 2C, also indistinguishable. Then the total number of excellence is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So excellence is actually about 10-letter words. So permutating this word becomes, it becomes 10 factorial, okay, all over, you have 4 factorial for n1, times you have 2 factorial for n2, times you have 2 factorial for n3. So simply this, right? So this is going to be equal to, okay, so 10 factorial is simply 10 by 9 by 8 by 7 by 6 by 5 by, you can simply keep it at 4 factorial since we have 4 factorial at the denominator, right? So divide all through by 4 factorial multiplies 2 factorial is 2 times 1, multiplies 2 factorial again is 2 times 1. So 4 factorial cancels 4 factorial over here. You're simply left with, so let's evaluate the numerator. 10 times 9 through 5, right? So 10 times 9 times 8 times 7 times 6 times 5. So that simply gives us 151200 divides by, you have 2 times 2, which is 4. So this is going to be equal to, let's divide that by 4. So that gives us 37800 ways. So this is the number of ways in which you can arrange excellence, right? So considering the indistinguishable object. So let's go back to Abuja. We started with Abuja. In Abuja, we have A repeating twice. So N1, you can simply call that N1 is equal to, that's 2 A's. That these are the indistinguishable objects in that permutation or in that word. Then total number of Abuja itself is actually 5. So N is equal to 5. So to permutate this, it simply becomes 5 factorial all over 2 factorial, because only 2 letters are indistinguishable. So this is going to be equal to 5 times 4 times 3 times 2 factorial all over 2 factorial. So 2 factorial cancels 2 factorial. 5 times 3 times 4 simply gives us 5 times 4 times 3 simply gives us 120 ways. So the word Abuja can be permutated or arranged in 120 ways. So this is it. That's it about indistinguishable permutations. Now we also have conditional permutations. Yeah, we also have conditional permutation, which is the last type of permutation, and that's the last thing we're going to be doing in this video. So in conditional permutation, you're given a condition. When you're given a particular question, you'll be given a condition. So for instance, let's say we are asked to find the number of ways of permuting the letters of the word hell such that the 2 L's will always be together. So this is a condition. You're asked to permutate hell, H-E-L-L, such that the 2 L will be taken together. That's a condition. So if the 2 L are taken together, that means you have this H-E, then L, then L. So you're simply taking the 2 L together. So this means you actually have 3-letter words here instead of 4-letter words. Originally, hell is 4-letter words, but by the condition of taking the 2 L together, it means the 2 L appears as 1. So the total number of letters shall become 3 letters, which is H-E-L, right? Therefore, the number of permutation of this becomes 3 factorial. You have 3 factorial. So this is equal to 3 times 2 times 1, and that simply gives us 6 ways. So taking the 2-letter L together, we can permutate hell in 6 ways. Alright guys, so that's it for this video. In the next video, we're going to be looking at combinations, and just like we've done here, we're going to be solving numerous examples in the next video to explain combination, and then in the subsequent videos, we're going to be doing a general question overview between permutation and combination. Okay, so I hope to see you in the next video. Stay blessed. Thanks.